thing that I picked up in your assignment, which is very good news for you guys. And it's something relating to your graphical user interfaces. So remember from the previous years, I think the last 2, 3 years or so, you were now required to develop your graphical user interface manually, like using um, using code. So let's go through this one. I see that they said, where did I see that? I saw it somewhere. That you are now able to actually create your graphical user interface using any of the two approaches. Okay, now I don't know where I saw that. Let me just go back here. Right, let's go through this whole thing together and then we can get into it. Use CMake and not QMake when setting up your assignment projects. Qt Designer should not be used to design user interfaces. Okay, so that's not the one. I thought I saw that somewhere, that you can now use it. Okay, so that doesn't change anything really. Right, Qt Designer should not be used to design user interfaces, and you're expected to manually set up GUIs to ensure that you properly handle memory using Qt's parent shared facility. Good programming practices should be followed. Follow standard naming conventions. Class names start with capital letters, and all of that, and all of that. Have proper GUI management settings, setting cursor focus, sequential tabing, clearing input widgets, and enabling and disabling buttons is appropriate. Provide appropriate user feedback. Your code should build and run without any warnings. Okay, so that's not it. I thought it was you guys when I saw that thing. All right, let's go into this diagram. So you've got this whole registration list diagram.
I think it's at the bottom, just above
yeah.
question 2. You'll
Okay,
find
something
it
is
there.
playing. Oh, it's not here. Okay, that's fine.
I was saying you'll find it. Go down, just above question 2.
Oh,
It's there.
sorry. Thank you. I'm not hearing you because my speakers are set to some other speaker, which is not what's in my ear right now. So I was wondering where the sound is coming from. Okay, perfect. Can you please start again?
I was saying it's at the bottom, just above question 2,
Oh, just above
where
question
questions
two.
two, where question 2 starts.
Yes, yeah, 100% correct. I thought I saw it somewhere. So now you
Yeah,
are
somewhere there.
in a conflict because they said you can decide on the design of the GUI and it can be done manually or using Qt Designer. That's what I saw. Thank you so much for picking that up. Yeah, that's what I saw. Now, that's a problem because this is the opposite of this. So you might have to confirm, but if you want to play it safe, just do it this way. Because if you don't do it this way and it turns up that they wanted you to do it this way, then you're the one who's losing marks. So I'm just gonna play it safe and we can just go with not using Qt Designer for designing a user interface, even though it's mentioned here. It's probably a copy paste question and they just didn't remove this part, which says you can decide on which interface you want to use to design your application. Also, based on the previous years, it's been done like that. You are not required to use, you should not do it with Qt Designer. So I don't know if genuinely they want to change this year and let you use it or not, but to play it safe, just confirm with your lecturers. And if you want to just be on the safe side, just do it manually. Okay, so let's go into, I'll read the question later, but maybe not today. What I want to do right now is go to create a new project. Now we've got all these types of projects that we create. This one is a widgets application, obviously. So you stay on widgets application, you choose that. Then you can go, give it a name, assignment 2, question 1. So whatever name you give it, do that. I think I'm going to go into COS3711. Right. And then next, CMake. So if you're on the latest version of Qt, it just defaults to CMake here. So it doesn't do anything. Just go next. Now here, if you're doing your GUI manually, you want to untick this. if we were allowed to use Qt Designer to do our user interface, we're going to leave this here. And then we can just use drag and drop. So playing it safe, we're going to untick that. Now, when it comes to these basic base classes, if you go with Q main window, that's the one with menus and stuff. So you can put like this one here. You can do, menus like this one if you need to do that. So there is no one way of doing
Can
user.
I ask something
Yes.
while on this point?
Mhm.
I went for a route that was a bit easier for me. That's
Mhm.
using a Qt Designer. So I ticked the generate form
Yes.
checkpoint there.
Mhm.
Is it possible to just reverse the process and go back there and untick it?
If if
Or
you're
should I
not,
start from?
yes, you have to start from scratch and create a new project, or you can still modify the one that you have to not use the forms that are auto-generated. But if you are scared of like things just getting complicated, you can just I'm assuming that you had no, yeah, because now you're gonna have to do the user's interface manually anyway. So look, there's nothing much that you're gonna need to reuse from what you have right now, which means just make a new project and untick it, and then you don't have to worry about going to delete the UI namespaces that are auto-created. You can just redo another project and just start from here because I'm assuming you had not done much. So this would be easier to just recreate and untick it.
Yeah,
Um,
I haven't done much.
yeah,
Thank
so
you.
yeah, right. So Q main window is you want to use menus. And remember, because you are allowed to be creative in terms of how you do your user interface, you can just do it whichever way you want. So you can use a Q main window if you want to do menus. If you just want a dialog, just like one window that you can maximize and minimize and restore, the one that looks like this window here, that is this minimize, maximize, and these three things here. That's your key widget, which is this one. A dialog is just a window like this one that you see on the screen. It's something that just pops and you can close it. That's a dialog, this one here. So a dialog doesn't have like the maximize, whatever, minimize options that you see, like for example, with this one here. This one is a widget. So usually, again,
Can I ask then?
yes.
I use the Q main window there. Maybe I'm jumping the gun.
Hmm.
Forgive my ignorance. I used the Q main window,
Hmm.
but I also took the widget and put it on top of the form.
Hmm.
Was I moving in the right direction?
You can, yeah, you can use a key widget as your central
But
widget.
it left me confused because some things were not happening.
Okay, that we're gonna have to deal with later, and then I can see how you are setting up your solution. But what I want you to do is to have a clear idea of what you want to do, and not just do things because they just happened and they have no idea why those things are happening, and you kind of just going with it. So let's first understand what you want. So now that I've explained, you've got two options, sort of. I wouldn't go with a queue dialog, but you still can use a dialog if you want, but I wouldn't go with a queue dialog. I would probably just choose between a Q main window and a widget. A main window allows you to use menus and show dialogues as part of your user interface. A widget is just a window and everything is on that window. So if you've read your assignment in full, you sort of should have an idea of the kind of user interface that you want. And I don't want to say use a main window or use a widget. I can use a widget right now. I might change later. So don't do what I'm doing. Do what you want to do, and remember, if you get stuck, I can always remote in and help you with your solution so that you can deliver exactly what you want. So, because when it comes to, programming, there's no one way of doing something. And I just let people just get creative, do things the way you want to do things, and I'll get you in your way, in your own, in the way that you understand your solution and the way that you want to do it. There are certain not negotiables, things that we have to do the way we have to do them, like design patterns, things like reading and writing XML, things like using Sax and setting it up. Those things are done a certain way, so we'll do it that way. But generally, your solution should just be what you want it to be, the way you design your user interface, all of that. Just be creative. If you get stuck, let me know and I can schedule a session with you where we sit and we go through your solution. So don't be scared to do what you really want to do. For now, I'm just going to go with a Q widget because it's easy. Main window is also easy, so I'm just going with the Q widget. Okay, next, then this is just your kits, whatever, next, and finish. Now I've got my project. Now, with CMake, you have this cmake.lists.txt. If you were using QMake, you've got a .pro function, a file, the .pro, which is your project. So that's the equivalent of this CMake here. So whenever you add a new class, you have to come and edit here. And whenever you add a new class, your IDE also just takes you here, and all you do is you just paste. That's how you add your classes, like I'm about to do right now. So yeah, otherwise everything else is just your widgets. This is my widget, which does nothing. This is my window. I'm gonna do my
Can
user
you
in.
can you
Mhm.
please repeat that this QMake and CMake
Yeah, I'm gonna go there right.
we're saying with okay.
It's your this is your project file. So it explains what files you have, the settings, and everything that you need to do. So you realize that when we get to XML, for instance, we're going to specify here that we want to use XML. I will tell you where and what you put in this file. But that's your project file, like what the name of your project, which is what you see here. You change that in here. So if you want to rename your project, I can just find and replace this, and I replace it with something else, and that updates the name of my project. It tells your what files make up your project. It's all here. So for example, I'll come back to this in a moment, but for now, I know that I need a class called registration. So obviously, I'm going to start with the registration class. And then I'll go to the subclasses, which is student registration and guest registration. And then I'll do person. Actually, I'm going to start with person because I need to use person in here. So I'm going to do person, registration, student, guest, and then final, I'm going to do my registration list. So when it comes to person, I'm going to have to add a new class called person. So obviously I come here, I right click. So you can just right click here and go, sorry, you right click your project, this one. Add, and then you go add new. And then I say I want to add a new class. So I double click that. And then I can say my class is person, like that. I go next, finish. So that's going to create your person.h and your person.cpp. So you can see that it puts them for you in here already. Depending on which version you are using, sometimes it doesn't put these automatically for you. You still have to go Control V, like paste, so that it can put them here for you. So that's what I wanted to mention. Just depending on your version. If it puts them for you, then happy days. If it doesn't, then you have to put them. You have to paste that these are your sources. It's just a list. That's all. Like I can just put one per line and so on and so on. So what I'm going to do is in my person class, I can go and define my person and implement whatever goes into person. And here I can just use everything that's in here. You are required to use not m_name. Your project sort of like they said, you must use camel casing for your class names, variable and function names, lowercase, camel case, right? So you can sort of like follow that standard when doing your class definition, which is in this case person. So I'm gonna put this on the side so I can copy these three data members or strings and these functions person, the constructor takes a name, qstring n, qstring a, qstring e, get name returns a qstring, get affiliation returns a qstring, get email returns a qstring, to string returns a qstring. So I'm just saying what's here already. That's your UML class diagram. So remember, when interpreting a UML class diagram, after your closing bracket, the colon is telling you what the function returns. Inside your bracket is telling you, yes, this resolution is bad. But inside your function is telling you the parameters. So it takes n, the qstring. So your UML class diagram does it opposite. So you start with the variable name and then the type. But when you're programming, you start with qstring, then name. Same goes for all these parameters that you see here. So it's qstring A, qstring E, qstring N. But when you are doing a UML, you start with the name, colon type, name colon type. So I'm gonna do this one exactly as it looks here, no changes. So let me just move this to the side, and I can just come here, and I know that everything under person is private because this hyphen means private, plus means public. So that's my UML class diagram. So I can then here, under private, I need to include a QString. So I can go hash include QString. And then here, I've got QString name. So I can just go QString name. You can do this on one line if you want, because they're all QStrings, or 3 lines, whichever way you want. QString, I can go affiliation, and I've got QString email. Now remember, from the diagram, it says M underscore name, M underscore affiliation. So I could use the same standard and just go, instead of M underscore, I can just go something like M name, use camel casing. Or here I can also go M affiliation or M email. But I'm just gonna use just name, affiliation, and email. So feel free, whichever way you want, just do it that way. Then my constructor here, it takes, according to the diagram, QString N, QString A, and QString E. That's my constructor. Again, just check your casing that you're introducing errors, because your language is case sensitive. I've got QString get name. I have QString get affiliation, sorry, like that. I have QString get email. I have QString to string, like that. These are my functions. Because these are all get functions, I can make these ones constant because they don't change any of your class data members. So these can all be constant, which is like some good programming practices. A constant function is a function that does not change this. That's a constant function. And you put constant at the end of the function, which means I'm saying it does not touch any of these things, doesn't change them. That's my person class. You can go ahead and implement your functions. Here you can just go right click, refactor, add definition in CPP. So it's going to do the definition for you. I have to delete this one. So now you can go and initialize your data members. You are required and recommended to use initializer lists. An initializer list, it means you're not going to go name equals n inside your constructor. Instead, you do it here at the function header. So you go name equals n, affiliate.
Sorry,
Yes.
Edmond. They're moving just a bit fast. Let me
Yes.
ask. There, when you're using a refactor there,
Yes.
can you go back a bit? Because I was doing that with a person, it worked. However, once I continued, there was I was missing an option that allows me to get, for example, into that get name and be able to implement. Yes.
Yeah. So once you add definition inside your CPP, like it has done it.
Yeah.
If you
Yes,
go,
initially it would happen like that, but as I was proceeding to other classes, I was missing that other option that lead. I don't know what causes that.
once you've done the, I'm just
Yeah,
guessing here. Once
it
you've
will
done
do
it,
something like this.
yes, because it's done, it's there already. So you cannot do it again because it has already done the definition for you. It's already there. So if I go back
Even
to,
with other classes.
no, it's only 4 cases where it hasn't done it. Like if I go to affiliation and I right click, it still gives me the option to add the definition. But once I've put the definition, because it's now here, I cannot go back to affiliation and say add definition because it's there already. So if it's not doing it for, like, if you go to another class, like here, it's, you cannot do it because it's there. So if it's not showing the option, it's because it's there already. Like for all these functions, it's there. So you cannot do it. But if it's just not giving the option, then yeah, I might have to look and see why. Yeah,
Okay.
so refactor, add definition, then you implement it. So you got this one, refactor, add definition, and then you just implement it. But anyway, so in here, get name should return the name, right? Return the name. Get affiliation should return the affiliation. I think so. Get email should return, oh, sorry, should return the email. And to string should return a string that's made up of the name, affiliation, and email, whichever way you do it. So yeah, you can just do it whichever way, as long as you've got a Q string with all those things, that's fine. I'm gonna do it this way for now. So I'm gonna put the name here, affiliation. I keep on messing up the spelling, and I'm gonna put my email here. And in my string, I'm just gonna have a string that says name, puts the name there, it says affiliation, puts the affiliation there, and email, puts the email, sorry, the email here. Okay, so that's the kind of string that I'm gonna build for my toString function. Yeah, I don't know if I can use a multi-argument version here, but I'm gonna leave it like that. Okay, so that's basically my person class. So it's basically just a person class. And you can go ahead and do registration and then this and that. So I'm gonna follow the same thing. We've got registration here, standard fee. So let's just read this. There are 3 types of registration allowed for the conference: standard, student, and invited guests registrations. Okay. The standard registration fee is the standard fee stored in standard fee. For those registered as students, the conference fee is half the price. Okay. So whenever a variable is underlined like this, it normally shows that it's a static variable. So when defining this class, I'm going to introduce a static variable, which is standard fee or constant, probably in this case. Then these are just your usual data members. M attendee is a person, so it's a variable of type person. Then booking date is a queue date, and then I've got the usual functions: registration, which takes a person; get attendee, which returns a person; get booking date returns a date; calculate fee returns a double; to string returns a queue string. So let's just do this class. Is it some come back here, right click, add new class, and my class is registration. Okay, next, finish. Okay, perfect. There it is. Everything is there. Perfect. I got my registration. I need to include person here, so I can go hash include, sorry, now it's person because this is my class. Now you're going to notice that they encourage you in your thing here to use forward class declarations in header files, right? I've talked about use initializer lists in constructors. That's what I did in person. Initializer list is where you initialize your member variables on the function or on the constructor's header like this, instead of doing it like this. That's your initializer list. Okay. Then forward declarations are used to, tell your compiler that there is a class ahead, sort of. So you're telling your compiler about a class which you're going to use, but at this point in time, it may not have been defined. So anyway, if I'm going to do a forward declaration inside registration and I want to use person, I don't do it like a hash include. I simply go plus person like that. That's a forward declaration. And in here, I can refer to person. That's how you do a forward declaration. So there are times when you can, I think when we do the memento design pattern, I'll show you like one way or one instance where you have to do a class a forward declaration and why you have to do it to avoid circular references. But let's not get into that for now because it might confuse you. All right, so let's look at the registration UML. I had it open somewhere, but I think I lost it. Where is it? I don't know where I put it. Did I close it? No, I didn't. Let me find it quickly. I think I closed this. Let me open it again. Okay. Oh, it was here all the time. Okay, perfect. So yeah, I'm gonna do registration. Let me move this on the side so I can see it. So I said here I have attendee, sorry, person like that. Yeah, so when it says incomplete type, whatever, if I was using a pointer, it wouldn't complain. But if I'm going to use a non-pointer version of person, then it's going to say you have to have a complete type, like something that has been defined already. So in this case, I won't be able to do a forward declaration. So you just have to do a hash include. So the good thing is your compiler tells you if you try and do a forward declaration and you cannot. So we've got person, we've got queue date, which is booking date. So I have to include a queue date here. I should include queue date. And I have my standard fee, which is public. So it goes under public. So I can go constant standard fee. Now, when defining a constant, it's a constant double, sorry. When defining a constant variable, you have to initialize it because you cannot define a constant and not initialize it because a constant cannot be changed afterwards. So according to this, I don't think we were given a value, but anyway, I'm gonna set it to something like, I don't know, 1,000. I can change it later if I need to. That's my standard fee. Then my constructor here, it takes a person, A. Then I've got my person gets attendee. I've got queue dates, get booking dates. I've got double, calculate fee. I've got queue string to string. And again, all these things can be made constant if you want because they don't change any class member variables. So you can also make these things constant if you want. There's no problem there. This one can also be constant. So anything that doesn't change your member variables can be made a constant. So that's my registration. We can, in the same way, go and, do our implementation. I'm going to have to delete this one. So this is going to set person, no, attendee, sorry, to A, and that's it, okay? Sorry. Then I've got get attendee, which is just going to return the attendee. So this is going to return that. Get booking date is going to return the booking date. So all of this is pretty simple and straightforward because I'm just doing these functions. Calculate fee should do some calculations. I don't know what it needs to do. Calculations. We'll come back to that. I'm going to just go return. I will leave it like this actually so that it can show me a warning that this function should return a double. It's not doing anything. So we have to read the question and figure out how this calculates. Actually, I don't think this function should be here even. I'll come back to this one. Okay, we'll come back to it. To string, this one should do a queue string. So just return your queue string here and format it the way you want. This should include the booking date and the details about the attendee. So I'll leave mine empty. But that's basically your registration class. Now let's come back to calculate fee. Whenever we talk about inheritance, we also have to touch on the concept of polymorphism. I won't go into the details of polymorphism, but one thing I would like to point out when doing this, which is very important, is that whenever a function is being overridden in the subclass, that's your subclass, this one is your base class. So your subclass is the class that is inheriting from the other class, which is the base class. So all functions that are overriding functions in the base class, overriding means re-implementing. In other words, it means that same function exists in the base, and we are simply providing another implementation of that function in the subclass. For example, calculate fee. Calculate fee exists in the base class. It's being overridden by both classes because it's there and it's here. ToString is another example. This function exists in the base. It's being overridden by student registration. It's being overridden by guest registration. The reason why your subclasses are overriding this function is because they need, number one, either to provide an implementation which does not exist in the base, or they need to add extra things to the one that the base is doing. For example, the ToString function. The ToString function in registration can print details about the person and details about the booking. Now, in student registration, we should extend this one to also include the qualification. And in guest registration, our ToString should do everything the one in the base is doing, plus the category. Now, remember, a subclass is extending the base, which means guest registration is everything in the base plus these extra things. A student registration is everything in the base plus a qualification. So if I print a student registration, I should be able to see the attendee, the booking date, and the qualification. If I print a guest registration, I still need to be able to see the attendee, the booking date, and the category. That's inheritance. So your ToString function in guest registration should not only print the category, it should also print these two here, plus the category that you see here. The same goes for the ToString function in student registration. It should build a string that has the attendee, the booking date, and the qualification. So if you've got a variable of type student registration and you say dot ToString, you want to see all the information here plus here. So keep in mind that whenever you're doing inheritance, you are extending. So a student registration is bigger than a registration because it includes everything in registration plus what's in student registration. I've just done a quick recap of inheritance. Okay, the next recap is your polymorphism. Every function that your base class is overriding must be made virtual inside your registration class. So calculate fee must be virtual in registration. ToString must be virtual in registration. So all functions that a subclass overrides must be defined as virtual functions inside the base class. So before we go too far, we do know that simply because calculate fee and ToString are being overridden in base classes, we must define them as virtual functions in registration. That's another recap on polymorphism. That means your calculate fee should be virtual here, and this one should also be virtual here. These are some of those basic programming principles that they would test during your exams. Do you know that? Okay, so that's covered. Now, talking about implementation, I was saying maybe we don't need to provide the implementation of calculate fee in the base class. Why? If we go back to the diagram, we're going to, this one is not drawn as a pure virtual function, as an abstract class, I mean. So perhaps calculate fee must have an implementation in the base. The only way to get those details is to read the question. So they said there are 3 types of registrations allowed for the conference. standard, student, and guest, which means it can be a standard registration, or it can be a student registration, or a guest registration, which means in all three cases, we can actually calculate the fee. So in this instance, that means calculate fee is not a pure virtual function, and this is not an abstract class. I won't go into the details right now of what are pure virtual functions and what are abstract classes, because it doesn't really matter for now. But all we know is that for those registered as students, the conference fee is half the price of the standard. And for those registered as guests, the conference fee is 10% of the standard, which means the standard is just the standard, which means whatever you store in standard, when we are in the registration instance, calculate fee is just your standard fee. So I can actually just say the calculate fee function inside my base simply returns standard fee. That's it. Doesn't do 10% or half. It just returns it as it is. But inside your student registration, we do know that it needs to be half the price of standard registration. And inside the other one, it needs to be 10% of the standard. So we can go ahead and define our our student registration class, which takes which looks like this. I'm going to copy it as it is and just define it. So we can go here, add new class, and my class here is student registration, and that's that. Okay, it's here. Perfect. Save that. Go to student registration. Now here I need to include my registration because I need to inherit from it. To inherit, public registration. That's how you do inheritance. So I'm now inheriting from registration. In student registration, I need to add the qualification. So it's a QString qualification. There we go. And I need to override the calculate fee function. So I go double calculate fee. Now in this constant is exactly as it is. Inside the subclass, you don't have to make it virtual unless there's another subclass inheriting from this subclass, then yeah, but that doesn't normally happen in this course. So inside your subclass, you just override it as it is. You only need to make it virtual in the base. Same goes for the toString function. So I can go QString toString as it is in the base. And you can see it just italizes it to show that, yep, that's an overridden function. It's virtual in the base. Now, my student registration here takes person A, and it takes QString Q. I think that one stands for qualification. Okay. Then I can go and implement my constructor. So that's easy. I simply need to, let me delete this one. So I need to, so whenever you implement the constructor of a subclass, you need to call the constructor of the base class, and you give it what it needs. It needs a person, so I give it A, and I can then initialize my qualification to Q. Again, these are all a recap of inheritance. That's how you always implement the constructor of your subclass. The constructor of a subclass must always call the constructor of its base and provide what it needs. So remember, just to make that a little bit easier to understand and also do another recap of inheritance, a student registration is an extension of a registration. It's one class. So a student registration is a registration plus whatever is in here. So if the constructor of student registration takes a person, what does it do with it? It simply gives it to the constructor of its base, because that's going to be one unit. Because remember, a student registration is actually all of this plus all of this. So the person that is being given to a student registration is actually being passed on to this one. So now this student registration now has the person and everything it needs. So you always pass whatever you need to push to the base via its constructor. That's how you create a student registration. Same goes for a guest registration. You take this person, you push it up to the base, and this becomes one unit. So a guest registration is always a combination of these two. A student registration is a combination of these two. That's the actual class. So whenever you implement the constructor of a subclass, you call the constructor of its base. Because remember, student registration is a registration plus everything in student registration. Right, then we do our calculate fee. This one, I think we know what needs to happen there. They said your student registration must pay half the price of the standard registration fee. So your calculate fee is simply going to return standard fee divided by 2. That's it. That's how we, this is public, so I don't have to do anything. I can just access it from the base. Yeah, that's your standard, that's your calculate fee. And then finally, you can do your toString function, which is supposed to do the, you can use what's called partial overriding. Partial overriding is where you call the toString function in the base. So you go registration.toString. So I'm calling the toString in the base, which is going to do, which is going to print the, because the one in the base is supposed to print this and that. So I call that one and I simply add the qualification. So whichever way you do it, but the idea is that I can simply say dot append if I want, and I can say append append qualification. Maybe just put a comma and go qualification colon and dot append actual qualification. So I'm just calling the toString function in the base and adding qualification and putting the qualification. And that's what I return. So that's my toString function in my subclass. And I'm done. So all of this is kind of basic programming, assumed knowledge from your previous course, like how to define your classes and how to do basic implementation of your classes. I know it's not very easy to remember, and yeah, it takes a bit of effort to understand what's going on. So I'd encourage you to get used to defining classes and implementing your functions. Understand these basics, like implementing the constructor of a subclass requires you to call the constructor of the base class. When defining a base class, you must put virtual behind every function that is being overridden by your subclass. And the rest is just, there's nothing much happening here. As you can see, I'm just putting return statements and initializing stuff. So these are not complicated classes. Like, look at this, just all return, 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 and then a toString function. Initialize your variables, that's it. Same goes here, initialize. This standard implementation of a subclass constructor. That's a very simple calculation. There's another way you can do this. All that matters is that you are taking this string from the base and adding the qualification details. So whichever way you do that, that's fine. That's how you build your string. So you can see that we haven't done any code which is like complicated. Just return statements. All these functions that we have implemented so far. Look at that. There's nothing complex going on here. This you have to do. See, all of this. It's just like basic, straightforward, basic functions. So that's what you need to do for all these classes. The same thing I've done for student registration. You do that for guest registration. And then once you're done, you create your registration list, which is a list of registrations, of registration pointers. And you've got your add registration, which takes this registration pointer and adds it to this list. Registration list, you use your QDeleteAll function to destroy this list. Is registered takes the name of the person, I think, I don't know what this is, and checks if it's registered. Total fee is the total of all the fees of your registrations inside your list. So you loop through your registrations and you sum the result of the calculate fee for each registration. So you loop through your registrations, you call calculate fee, and you sum them together. Total registrations. I don't know what this is doing, but I think it's described somewhere here. There. An instance of registration list contains a list of registration pointers. No two registrations are allowed to have attendees with the same email address unless the names are different. You should be able to query a registration list whether a person by the name is already registered for the conference. A registration list can also retain the number of attendees that are registered for the conference from an institution. Similarly, you can request the total registration fees for a type like registration, student registration, guest, or all of registrations. You are expected to use Qt's meta object system to access the type of a registration in registration list. Okay. For this last part, we need to do some talking around what is Qt's meta object system and how does it work and how do you use it in this particular instance. That is going to change a lot of things in our solution. This one last statement is going to change actually all these classes that we've created so far, all of them. Registration, student registration, and guest registration, which I haven't created yet. But before we get there, do your classes like this. The only thing that will change is not your implementation. The only thing that will change is just your class definition. We're just going to add some things in here. One thing actually, or two things, so that we can use Qt's meta object system, but we are not there yet. So we'll discuss what is Qt's meta object system and what is it that we need to change in order to use this meta object system. This system is only required for implementing this one function, the last one, total registrations, because it's being given a type of registration and it must return how many of those registrations exist in this registration. In other words, how many standard, how many student, how many guest in this function. So we're going to do what's called reflection in this function, this last one. Otherwise, outside of this function, everything else is pretty normal. So we are going to need to discuss the concept of Qt's meta object system when we get to that last function, which is a concept you need to understand and learn how to use. We are going to cover reflection in more detail when we revisit assignment 1, question 2, because that is where you should have done reflection. But because we haven't done that yet, we are just going to discuss about the meta object system. So a little bit of reflection so that we can finish this function. Otherwise, the total fee is going to calculate the total fee for what? Let's see. They mentioned somewhere. Actually, you know what? That's where we need to use the meta object system in calculating the total fees. Yes. Yes. So we're going to use this for the total fee. That's where we need to use it. What about is registered? Checks if a user is registered. I mean, if an attendee is registered, so it gets a name and it checks if there's an attendee with that name or email, I think. Then the other function that we need to figure out is total registrants, which is going to, yeah, this one uses the name, that's fine. Number of attendees that are registered for the conference from an institution. Yes. So you need to be able to understand how many attendees are registered. Well, there's only one attendee per registration. So counting the number of attendees is the same as just counting the number of registrations, because as you can see, every registration can only have one person, which is the attendee. So total registrations is just counting how many registrations you've got in this list. And it says number of attendees that are registered for the conference from an institution. You can also request the total fees for a type. So for these two functions, total fee, total registrants, because you need to use a type. And for these two functions, you need to use the meta object system. We're then going to talk about how to use this meta object system to figure out how many registrations of each type exist in this list. Because remember, this list uses a pointer of type registration, but you can put instances of type registration, student registration, guest registration. So within this list, we're going to have 3 different types of registrations here. And we need to be able to count how many of each exist in this list without using some get type function that tells us if this instance is a guest registration or a student registration. We are simply going to use the meta object system. And that system, as we loop through all these instances inside this list, it's going to allow us to know whether the actual instance stored in this list is an instance of type registration, an instance of type student registration, or an instance of type guest registration. So what I need you guys to do right now is forget about these 2 functions and let's try and finish everything else in terms of setting up our classes. Then after that, you then need to set up a user interface that allows you to do this. For your user interface, look at the registration list. You have an add registration function, which allows you to create a registration and add that registration to a list. To make a registration, what do you require? Look at the registration class. You need a person and a booking date. Okay, to make a person, what do you need? Look at the person class, a name, affiliation, email. So for you to make a registration, to add a registration, as per this list, you're going to need to make a registration instance. To make a registration instance, you're going to require a booking date and a person. To make a person, you need these 3. So in other words, to make a registration, your user interface should cater for the name, the affiliation, the email, and the booking date. This is the information you need to add a registration. Your user interface should allow you to check if a user is registered. How you do it, it's on you. But all you need is a way to enter the name, and we get a message that says, is already registered or not. Your user interface should allow us to calculate the fees for each type of registration or all of them. You can go with a drop down, you can do whatever you want, but this is the functionality required. We need to be able to look at our registrations here and calculate the fees for each. Also, we need to be able to calculate how many registrants we have. Your user interface should allow us to query that information. How you design that interface, what widgets you use, and how you want it to look, that's entirely on you. Think about it. Try and sketch a small user interface. See if it's going to work perfectly the way you want it to work. But the functionality required is making a registration, checking if a user is registered, calculating the total fees per type of registration or all, and checking the number of registrants per type of registration or for all of them. That's what you have to understand and factor in when creating your user interface. So what I would say is these classes do not require your user interface. So you can do these classes and finish. Say for these 2 functions, right? Which we need to talk about later. Do your classes, done. Then do your user interface, right? And then done. Then once that's done, we need to then use these classes inside our user interface. And we'll talk about that. Like, how do you then connect your classes to your user interface? Like, if somebody clicks add registration, your user interface should go and collect all this information and make an instance of a registration which it then adds to your list. That's what your code is doing, and so on and so on. So pretty much that's question one. So I think I'm seeing you guys tomorrow. Probably, I think so. So spend some time on the. I'm not seeing you tomorrow. No, I'm seeing you on Sunday. Okay, that's fine. So spend tomorrow working on your classes, working on your solution. Reach out if you need help. Let's figure out how can we can help each other. And then on Sunday, we're going to pick up from where we've left today. I'm going to finish off by adding my guest registration in my registration list. And I'm going to do my user interface alone by myself. And you do your own by yourself. And that way, everybody's going to have a unique and a different user interface. Whichever one you go with, we'll then see how I can assist you to complete your solution with your user interface and the way that you want to wire things and the way you want your solution to work. All right. That's it. So yeah, you get the video, so you have a chance to replay it
Yeah.
and watch this again. But I encourage you that this course needs you to practice. If you don't practice, you won't get it. So practice, get stuck. That's how you learn. And my job is to unstuck you if you get stuck. So yeah, let's start practicing. Let's start writing the code. Let's start trying to figure things out. And then, yeah, let's start moving because we don't have much time and we have a lot of ground to cover. So question one is just setting us up. And then we're going to talk about reflection. It's a few lines of code to do this, so don't worry about it. And then finish question one. Then we go to question two, which is going to be excellent. But question one lays the foundation. It's what you want to get right first, because everything else is going to build on question one. So if you don't get question one right, or if it's not working, then everything else downstream will not work as desired. So we need to make sure that it works and it works perfectly. Okay, cool. All right. Cheers. You guys have a good night.